we're going to take a look at what is the axis of symmetry. And the axis of symmetry is the line that runs down the middle vertically through a parabola that cuts it into two perfectly even halves. And so right in the middle of the parabola is where we have our vertex actually. And so we're looking for the line that cuts right through the middle. Okay, and so this red line symbolizes what we call the axis of symmetry, or as I like to simplify it to, just the AoS. Okay, so the axis of symmetry. Now you can also find a couple of things based solely on the fact that we have a graph here. And one of those things is the y-intercept. And so the y-intercept is where the parabola is going to cross the y-axis. So our y-axis is right up here. And so it's the parabola actually crosses the y-axis at this point here at -6. So the y-intercept is at -6. And another way that we can tell that actually is because in the equation that's in standard form, again, you may recall that the c value is always the y-intercept. And so here, our c value is -6. Let me just quickly write. There. So that -6 is the y-intercept. Based on the graph and the graph alone, we can also determine what the zeros are for this particular graph. And so here we see that the parabola crosses the x-axis at both -1 and at +3. So there are two zeros for this particular graph. Okay, and we've drawn in the axis of symmetry already, the AoS. And so quickly, let's identify what special point does the axis of symmetry actually pass through. So the only point where the axis of symmetry actually intersects with the parabola is at this point right here, which for this particular parabola is the vertex. And in fact, the axis of symmetry will go through the vertex of every parabola. Okay, and that's very significant. So if we want to figure out the equation of the axis of symmetry, we're actually looking at, well, at what point along the graph is the axis of symmetry. And so for us, the axis of symmetry is always when x is equal to whatever that piece is. So in this case, the equation of the axis of symmetry, the equation of the axis of symmetry is actually at +1. Okay? So we know that this equation, or that this axis of symmetry rather, goes through +1 all the way down to when it intersects with the vertex. And so in this particular situation, our vertex, the coordinates for our vertex are at 1, -8. Okay? And again, the vertex, as we know from vertex form of an equation, is the same as the hk value. So we can say that the vertex always intercepts the x-coordinate of the vertex. And we can generalize to say that the equation of the axis of symmetry is always when x is equal to whatever that h value is. And so when we have the equation for the equation of a quadratic relationship in vertex form, we can always figure out what the axis of symmetry is going to be. If we carry on, we want to identify, is there a way to figure out what the axis of symmetry is if you weren't given the graph? So for example, in the previous equation that we were just looking at on the last slide there, this was the quadratic relationship in standard form. Okay, and so we had gone through and we determined just based on the graph itself that the zeros were -1 and +3. Okay, so we determined that from the equation of above. You could also factor it and get the same thing. So what's really important about the axis of symmetry is that it is halfway between the x-intercepts. It's right in the middle. Okay, and so to calculate it, if you didn't have the graph, you could just calculate it by figuring out the average distance between the two zeros. So to do that, we want to figure out the average distance between any two things. Again, to figure out average or mean, what you're looking for is you take the two values, you add them together, and you divide by the number of values. So here we would do -1 plus +3, and then divide by 2 because there are two values. And so what we will discover is that -1 plus +3 is equal to +2. And positive 2 divided by 2 equals 1. So therefore, the axis of symmetry happens when x is equal to 1. Okay? And so we can, if we look back at our previous example, if we scroll down here, we see that the axis of symmetry, this vertical red line in the graph, does in fact pass through positive 1. Okay? So that's a very helpful thing to be aware of. So this value, it's also the x-coordinate of the vertex, so you can substitute that value into an equation to figure out the y-coordinate if you don't already have it. So because we know that the axis of symmetry, the AoS, is equal to x equaling h, okay, what this tells us is that if we know what the axis of symmetry is, which in this case it's positive 1, we determine that up here, we can substitute that positive 1 into the equation. So for that graph, the axis of symmetry happens when x equals 1. So I'm going to substitute x equals 1 into this equation, and then I'm going to solve for x. So I'm going to end up with y is equal to 2 times 1 squared minus 4 times 1 minus 6. Okay, so I've just substituted into my x values. So now I'm going to solve this. I'm going to use my order of operations, my rules of Bedmas. So 2 times 1, because 1 squared is just 1, negative 4, negative 6. So y is going to equal 2 minus 4 minus 6. So y is going to equal positive 2 minus 4 gives me negative 2. Negative 2 minus 6 gives me negative 8. Okay, so the y value at the vertex is going to be negative 8. So I now know that my vertex should be at 1, negative 8. Okay, and if I go back, okay, and I look to verify that because I had the graph on the previous page, I should see very quickly that that is in fact the case. So if I go back to the original graph, if we look down here at the vertex, here we are at the vertex at the very bottom of the parabola, and sure enough, the vertex is happening at coordinates 1, negative 8. Okay, so we can do that. We can figure that out whether or not we have a graph or just an equation. So it's a very useful skill to be able to have, to know that we can figure out not only the axis of symmetry from the two zeros, but once we have the axis of symmetry, we can substitute that into the equation in order to solve for the y value at the vertex and determine what the vertex is going to be.